project is we were supposed to build a fuel-efficient aircraft. So we built a model aircraft, small, so we can get it down, figure out how to build one. And then outside, if you actually go to the left on the balcony, there's a larger aircraft, and we built that. And later on, we're gonna have a camera mounted on it.
Okay.
First, we built the fuel cell part, and solar energy is powers that solar panel and sends it through there and powers the cars. And the airplane, we built it. It runs on fuel, oil, and stuff, and it flies and stuff. And it took about a month to about 2 months to build it. We worked 2 days out of the week. We discussed about it, figured out how to fly it, learning how to fly it. We should be flying it by the end of the school year, maybe.
3 to 2 months to build it. It has a 49cc motor. It runs off gasoline and 2-cycle engine oil. The plane is basically complete. The only thing that we need to do is hook up the electronics. Next year we should be flying it. And the company wants to distribute or give us a camera to test on the plane next year when we fly it. And the camera is a 360 camera, and they want us to test their camera. And their camera works with the air particles. They want to measure like the pollen and stuff. And that's basically it. We have 2 planes. The other one that we use or get is the one to train on, and this is the larger one we have. It's a 4-year program. It's an enterprise program at Michigan Tech. And that's basically it.
This is our manufacturing. This is where we're going to be manufacturing our basic business style stuff that's going on here. So we have a planetary gearbox here that turns the motors, allowing us to go up or down. We have a brushless that turns the DC brushless motors this way, and we're able to move it this way and be able to do omni control and just move around in any sort of direction. We have over here is our competition sub. This right here we have 3 stationary cameras. We have 4 stationary motors, and we have our valves, which is our main part of steering and submersion. What happens with the dynamic valves is what we have here. Is that when we set this in the water, we pump air through here, through our tether. When we pump the air through here, it allows water to not be in there. It creates an air pocket. When we stop pumping air, we open a valve that also goes through our tether. When we open that valve, it allows water to seep into the PVC, allowing it to sink gradually. Here we have an arm, which is for one of the tasks. We have the arm is powered by this gearbox right here, which spins the gears inside, allowing it to open and close. We have here, which is a rotisserie on the bottom. This rotisserie is put inside of a hatch, which then we turn the entire sub itself around, allowing it to spin the hatch open. And we have tusks in the front here, which are allowed to pick up certain pods that we are supposed to pick up, bring them to the surface. Then we put this on an angle and slide them right back down where we need to be putting the PVC pods.
Okay. Go ahead.
We're from the Traverse City area, from Central High School, and this is the ROV team, remotely operated vehicles. So you put them underwater, and they can explore the rocky areas, sand areas deep down. This one specifically is designed for the deep water. It allows the onboard battery allows it to go further on a longer tether because the power loss on the long tether deletes it, so you can't run the motors. So it sends a signal, flips a relay, battery power on board, runs all the systems. This one's our competition one. It gives us like a precision control. It's able to go forward, backwards, sideways, and spin on a dime, as well as tilt to about a 15-20 degree tilt ratio. This one was built just specifically for speed, just to see how fast we can make one go. And then this one's our workhorse. It's got basic controls, and what usually carries our data probe. It's right now sitting on the bottom of the lake, but usually this would grab it by a hook, move it out to a location, set it down, and the onboard battery on board would take over.
Okay.
Alright, this is our project. We're from Saginaw, Michigan, Arthur Hill High School. Our mission to go green. What we're doing is we live in an urban society. So we plan on taking the area near the eastern corridor of our school. Our school is shaped H. We're going to take this area and we're going to reconstruct it and remake it to make it a green area, greenland. So it'll also be educational. So elementary and middle school students will be able to come in and learn stuff about the Michigan-grown plants, Michigan animals.
Class is a new class at our school. It's hands-on outdoor kind of class that was established, and the teacher right there is started the whole thing. So they built. We pretty much do things for the community. We also home energy auditing right there, and switch out trees monitoring. I don't know. Also, you guys working on the camera.